Hello and welcome to this film about how we convert mass into moles and vice versa really. It's the third of the films about quantitative chemistry, or calculations in other words. So hopefully by the end of this film the things that you'll be able to calculate are how we find a molar mass from the periodic table, or a formula mass otherwise known as, and how we can relate the quantities represented by three different symbols: capital M, and little n, and also to try and make some connections between what we're learning here and what we learned about in the last film where we looked at Avogadro's number. Okay, so without further ado, let's look at what we mean by molar mass, and before I do that, let's just have a look at all the different names for this thing, which can be quite confusing for people, but all these things basically mean the same thing. Molar mass is also known as formula mass, molecular mass, capital M, relative formula mass, relative molecular mass. And I suppose, strictly speaking, that the second and fifth ones, they're molecular mass and relative molecular mass, they can only apply to covalent substances because they're the only substances that have molecules. So you couldn't talk about the molecular mass of sodium chloride, it wouldn't make sense because it's ionic. But basically we're finding the same thing in all of them. And what we're describing when we're stating a molar mass is how much 1 mole of that substance weighs, in grams usually. Okay, so it's the mass of 1 mole of a substance. And if you think about what that's telling us the number of grams per mole. So the units are grams per mole. Okay. Now let's have a look at just a few examples where we would calculate M. Now to calculate big M, or the molar mass, or the formula mass, we need to know what the formula is. So what's the formula of magnesium? Well, it's Mg. If I look up in the periodic table how much, or what the relative atomic mass of magnesium is, it's 24.30. That means that every mole of magnesium weighs 24.30 grams. Okay, so because there's only one magnesium atom here, I'll just take one of these and it's 24.30 grams per mole. Now, again, strictly speaking, if I was asked for the relative formula mass here, I wouldn't need to put a unit because it would be a relative quantity, okay, but I'd have the same number. What's the formula of chlorine? Cl2. If I look up chlorine in the periodic table, it's 35.45 for its atomic mass. So the formula mass of chlorine has to be that times 2, which equals 70.9. If that was a relative formula mass, it would just have no units. If it's a formula mass, it's grams per mole. We can actually talk about the molecular mass of chlorine, because chlorine is a molecule. Carbon tetrachloride, well, we've got to remember how to turn that name into a formula. If we can't do that, we're going to be completely stuck. So it's very important that we've mastered the basics. Anyway, there's the formula of it. So it's 12.01 for carbon, plus 4 times 35.45 for chlorine. Not quite sure why I put those brackets in the previous one, but anyway, if we add all those up, we get 153.81 grams. Aluminium oxide. I ought to be able to figure out the formula by knowing the charges on the ions. If I can't, I'm going to be stuck with these kind of questions, so it's really important that we learn how to do this. Anyway, 2 aluminiums, 2 times 26.92, plus 16 times 3 for the oxygens, and altogether that makes 101.84 grams per mole. Now, if you're wondering, well, how many decimal places or how many significant figures should I give these things to? Well, remember, these are data book values, so-called, so we can trust them completely to be what they are. Okay, calcium nitrate, again, I'm not looking in detail at how we're going to decide these formulae. Okay, but calcium's got a 2+ charge, nitrate's got a 1- charge, so that must be the formula of calcium nitrate. How many oxygens have I got? I've got 6 oxygens, and I've got 2 nitrogens, so 2 times 14.01. And I've got a calcium there as well, only one of those, so plus 40.08. And altogether, if you add them up, it's 164.1 grams per mole. Okay, so that's how we find a molar mass. Now, where can we use a molar mass? That's another thing. Okay, so using this symbol capital M with another symbol little m, which is going to refer to the mass of a substance, usually in grams, but it could be in any unit. But if your molar mass is in grams per mole, then the mass will be in grams. And this is, as before, it's the number of moles. Now you could look at the unit quite simply here of molar mass in terms of the fact that it is grams divided by moles, and then that tells you that molar mass is grams mass divided by moles. Or you could go, well, okay, let's imagine I had a substance that weighed 10 grams for every mole of it that I had. And if I had 2 moles of it, how much would it weigh? Well, obviously, hopefully, 20 grams, because you're multiplying these two numbers together. So in other words, if someone's asking you the mass of something, you're taking the number of moles and multiplying it by the molar mass. Okay, so a common sense approach to this allows us to figure out the formulas that we need. And then I could rearrange this to find n, the number of moles, and that would be little m divided by big M. Or I could use the units to decide what the triangle is going to look like. Molar mass, grams divided by moles, and then cover up mass, and I've got number of moles times big M. Find the number of moles by covering it up, I've got little m divided by big M. However I do this, I need to be able to make sure that I know what these formulas are. So whether I choose to remember them or figure them out, it's entirely up to me. Okay? Now then, let's use one of the formulas that we've just covered. What is the mass of? Remember, this is mass equals, and then that will be number of moles times the molar mass, or the formula mass. What's the formula of iron? It's Fe. If I've got 10 moles of it, then N is 10. Multiply it by 55.85. I've got a bit of a problem here because I've got different numbers of significant figures and I'm multiplying two numbers together. So I've got to use the fewest number of significant figures in my answer. So that would be 558.5 grams, but I'm going to have to reduce that to two significant figures. So 560 grams. What's the formula of iodine? I2. So this is going to be 0.0136 as for the number of moles, multiplied by the molar mass, which is 2 times 126.9. If I plug those numbers into my calculator and use 3 significant figures in my answer, I get 3.45 grams. In this particular case, I've got 3 significant figures here. CH4 is methane. If I don't know that, I'm stuck. I can't do the question. Learn your ion list. Okay. Anyway, adding these all up, we've got 12 and 4 hydrogens. So just skipping out some of the working here, this would be 2.56 times 10 to the 3, multiplied by 16.05. Try not to skip out your working in IB questions because they do award marks for it. Okay, so this would be, again, 3 significant figures. So 41,088 grams, but that's 41,100 grams to 3 significant figures. And 17.5 moles of potassium sulfate. Got to be able to figure out the formula of potassium sulfate, so that's K2SO4. I'm skipping out the working again because I want to get through this film quickly, but try not to do that in a test or an exam. So the molar mass of that is 174.26, 17.5 multiplied by 174.26 gives me, and again I've got to use 3 significant figures in my answer, 3,050 grams, which I could turn into kilograms if I wanted to, but I can just leave it in grams. Okay. So, moving on, and using a different type of formula, how many moles are there in these different masses of substances? So this time I'm being asked to find the number of moles, which is N, and that's little m over big M. So carbon 12, what's the molar mass of carbon 12? Well, 12 grams per mole. So 24 grams of it, you might be able to instantly tell in your head is 2 moles, but it would be 24 grams divided by 12 grams per mole. And this is another useful way of checking that you've done something right, because the grams are going to cancel here and the per moles is going to become moles. So that would be 2 moles. And you know if you've got the right units in your answer, you've probably used the right formula. 3 kilograms of fluorine gas, that should actually be 2.0 moles because I've got 2 significant figures here and here. But anyway, 3 kilograms of one significant figure here. So fluorine gas, that formula is F2. So the molar mass will be the mass of 2 fluorines. So I'm going to take 3 kilograms, that's 3,000 grams, but I only know that to one significant figure, divided by fluorine, which is 2 times, where are we, 19 grams per mole. So in other words, 3,000 over 38, and that to one significant figure is 80 moles. 150 milligrams of ammonia. Well, first of all, ammonia is NH3, which we need to know. 150 milligrams, that's 0.15 grams, or 0.150 grams, because I know it to 3 significant figures here, divided by the molar mass of ammonia, which again I'm not working out because we know how to do it, and so you can check that for yourself, divided by 17.04, 3 significant figures in my answer, so 8.80 times 10 to the minus 3. It's a bit late to be telling you this really, but it'd be good if you can pause the film before you see these calculations just to check that you can do them yourself. So anyway, here we are. Here's the last one. MgCl2 is the formula of magnesium chloride. Got 260.45 grams of it, and I'm dividing that by 24.31 plus 2 times 35.45. Okay, and that equals 2.736 moles, 4 significant figures, because I had 5 significant figures there, but only 4 in that data there. Okay, that just leaves one thing, which is to kind of link up what we've learned in this film with what we were covering in the last film. Now, how many atoms are there in 32 grams of oxygen? Well, in the last film we didn't have a formula that connected N, the number of atoms, to the mass. Okay, but what we've got now is we've got formulas that connect the number of moles, which is the number of particles over Avogadro's number, and the number of moles, which equals the mass over the molar mass. Okay, so here we've got little n appearing in both these formulas. So in other words, if first of all I can figure out what 0.32 grams of oxygen is in moles, okay, so the number of moles is equal to 0.32 grams divided by the molar mass of oxygen, which remember is O2, so that's going to be 32. That equals 0.01 moles. So I've got 0.01 moles of oxygen molecules, I've got twice that number of oxygen atoms, so therefore I've got 0.02 moles of oxygen atoms. And 0.02 moles, well, how many particles is that? Well, the number of particles is the number of moles times Avogadro's number, which is n times L, which is 0.02 times 6 times 10 to the 23, or rather 6.02 times 10 to the 23. And that equals, I should be able to do that in my head, but I'm being a bit lazy here. So that's 1.204 times 10 to the 22 atoms. Okay, how much would 5 times 10 to the 20 molecules of hydrogen chloride weigh? I'm trying to find a mass. And in order to do that, I want to take the number of moles times the molar mass, but I don't know the number of moles yet. I can find the molar mass of hydrogen chloride because I know it's HCl. So that, if you add up hydrogen and chlorine, is 36.46. Okay, so this is going to be the number of moles times 36.46. But first of all, I've got to find the number of moles, and the number of moles is equal to the number of particles, 5 times 10 to the 20, divided by Avogadro's number, 6.02 times 10 to the 3. So the number of moles is 8.3 times 10 to the minus 4 moles. Put that number into here as my number of moles, and I find that I've got 0.03 grams. Only one significant figure here, because my weakest piece of data has only got one significant figure. Whew. Well, that was quite a lot of calculations, and hopefully they made sense, and hopefully now you know how to calculate a formula mass. and you know how to relate quantities that we're representing as a shorthand by using symbols capital M, little m, and n. At the end there, you might have linked what you learned in this film with what you learned in the last film. Hopefully it makes sense. If it doesn't, ask or post a comment.